Hello, this is Dan Niswander. Welcome. You are tuned in to the first edition of the podcast, Envirological Solutions. What is that, you might ask? Well, we're going to be talking about a lot of different things in this program. In the physical world, of course, we'll be talking about climate change, also policies around the world when it comes to the environment. We'll be talking about energy efficiency in home improvement as well as in commercial properties, economics, and much more. But the environment is also inner. Mental state, joy, happiness, peace of mind, enlightenment, and so much more, in addition to what you could call the outer environment. So in this premiere episode, we're going to be talking to Erika Podest, who is an earth scientist in climate studies at JPL NASA in Pasadena, California. So here is our interview. Erika Podest has a PhD and is a JPL NASA scientist with the Carbon System Ecosystem Group. She is an earth scientist. Welcome back to the Now Man Show.
Thank you, Dan. It's really great to be here.
And it's great that you're back, because there's a lot to talk about. I mean, and since we last talked, you know, we know that you work with the SMAP program, which is a satellite that goes around the Earth how many times a day? Or
a couple.
A couple times
yeah.
a day. And it does swaths and gathers data of the moisture in the soil all over the planet. That's just amazing to me. And then you look at that data, and then you go to the northern high latitudes in person, which is Alaska, Russia, Eurasia, and then you put all your data together on there. In the last year, just since we've last talked, what have you seen? What have you discovered?
Okay, well, first of all, let me tell you a little bit about SMAP. We just came up on our 2-year anniversary since it launched.
Oh, wow.
And SMAP has been measuring not only soil moisture globally, but it also measures what's called the frozen or thawed state up in the northern high latitudes.
So like Greenland? Or?
That means whether the land surface is frozen or thawed. That's the length of the growing season, right? So the northern high latitudes are driven by strong seasonality. So you've got the 4 seasons that are very well marked. And one of the concerns about the northern high latitudes is that these areas are ground zero for climate change. This is the canary in the coal mine. And the first areas and the areas where there's the largest impact in terms of increasing temperatures. So what we're seeing is that the growing season length, that's the period of time when the vegetation grows, is getting longer, right? So during this period of time, there is a very large exchange of gases between the atmosphere and the vegetation. And you'd think that that's a good thing, right?
Because you're seeing more growth,
that's right.
Or greenery.
So there's more CO2 being taken up from the atmosphere by the vegetation. But it's a complex system, and we're seeing that there's less water availability, and so trees become stressed and they basically shut down. Or there's more and more days now where you've got very high temperatures, and this stresses out trees as well. So it's not only about vegetation either. You've got soils up in those areas that have been frozen for hundreds and thousands of years. These are called permafrost soils, and they store huge amounts of carbon.
Yes.
So the concern is, as temperatures increase, these soils are thawing and releasing this large amount of carbon in the form of carbon dioxide and methane into the atmosphere. That's on the terrestrial side. Those are the main concerns. And then on the ocean, you've got less ice.
Yes.
And so look at the poles as the refrigerators of our planet, right? So the white area reflects the sun's energy back into space, but when you remove that white area, you expose the dark surface, which absorbs the sun's energy. And so what we're seeing is that there's less ice, sea ice, and there's more water exposed, which causes even more heating.
And so there is a distinction between now this is technically a natural process too, right? But you're also seeing the human impact, right, of the changes.
Yes, absolutely. I mean, obviously the seasons are natural, but things are changing very rapidly, and much more rapidly than what the ecosystems can adapt to. So we're looking at
how does that configure? I mean, you're talking, obviously that's an imbalance, right? If so, the human impact is changing what naturally would happen. So it's like you and I, having to make an adjustment with our bodies. It's the Earth's body.
Correct.
So how is that, when you say that's rapidly changing, how is it rapidly changing from what you can see?
Well, in a very short period of time, you've got increasing temperatures that are leading to less snow, less water availability, less sea ice, more of this permafrost thawing. So you get all of these changes. There's the tundra up in the northern high latitudes. Wildfires were rare things in the tundra. Now they're common events. So you have all of these very rapid changes that within people's lifetimes, they can notice these changes.
Now, is this methane, or is that when you see those fires, is that methane that is putting into the atmosphere?
So it's being both. It's CO2 and methane. Plus, these fires are causing degradation of the permafrost.
Yes.
So there are many different implications.
There's a lot, and it's like a domino effect too.
Correct, absolutely.
So that's why you were saying that this is ground zero for climate change.
Absolutely, yes.
Because you have to monitor what happens there, and then you can understand the effects, globally.
Yes.
Right?
Yes.
So by looking at that through space and looking at that on the ground, I mean, there's incredible ways now to get data and to say, look, here's what's going on. That being said, now carbon dioxide is Keeling pointed out as points per million, right? So let's say in the last few years, how much has that number gone up? Do you know what it is right now?
So right now we're about 405 parts per million. And just to put things into perspective, in the last at least 500,000 years, that concentration of CO2 wasn't above 280, 300 parts per million. So we're really, in terms of us humans living in this planet, these are unprecedented times.
Wow. And if we don't stop this, and as Keeling pointed out, it's rapidly rising.
Yes.
If this doesn't stop, I mean, will we see more extremes of everything, of what we're already seeing?
Well, yes. So if you think of CO2, it's a greenhouse gas, right? So it creates it traps heat in our Earth. And if you increase the concentrations of this gas, basically you're increasing that blanket around our Earth. And things get hotter, and there are consequences with that. So you get melting ice, increasing sea levels. You get many different effects from increasing temperatures around the world.
And is there anything that you know of that significantly is being done to reverse that?
I think there are many different things that are being done, anywhere from people coming together to try to make a difference to policies. So you've got the United Nations Climate Change Convention, you've got the IPCC, you got the Paris Agreement, right? Where nations came together and agreed that something is happening and we have to try to put a stop to increasing CO2.
Yeah. So briefly, let's talk about something that's a little fun, and then we'll come back and we'll end this segment. And please come back to the show.
Oh, absolutely.
We'll end it with talking about what we personally can do, and we can give that to the audience. But every year, JPL NASA, which is here in Pasadena, they have this wonderful open house. It's just and I had a great time. We had a great time. The little kid came out, especially looking at those models of the satellites and the rover and the, and going into mission control, where everybody was at. So we'll definitely keep the audience posted on when, if you're here in the LA area, you can actually go to actually JPL NASA and see all this stuff for yourself. It's incredible. I had a great time. Thank you so much. Now, we'll bring you back, but in closing here, I know we've talked about this before, the 3 R's, but there could be other things in addition to that. Tell us what we all can do, in our own individual ways to make the world maybe less carbonated.
Yeah, absolutely. I think I like to go by the 3 R's: reduce, reuse, and recycle. But you can add to those R's, like refuse or. I mean, there are many things that you can do, and I think just becoming aware of the resources that you use, anywhere from what you buy, the amount of plastics that you buy, to the amount of water that you use at home, to the amount of electricity that you use at home, to how often you use your car.
Yes. Use public transportation a lot more.
Correct, yes.
Use hybrid cars or use electricity more for transportation.
Correct, or plan your routes so that it makes sense and not having to go back and forth. I mean, little things. I think once you're conscious of the resources that you use, then you can really understand how to cut them and how easy it is to cut them, and you don't have to change your lifestyle.
That's fantastic. Erika, thank you so much. It's always a pleasure to talk to you, and let's pick up this conversation when more data comes in. Erika Podest, who is an earth scientist at JPL NASA. This is Niswander, and you're watching The Now Man Show.